Okay, the design of the pressure vessel which is subjected to the internal pressure. Okay, for the cylindrical shell, to determine the thickness, you may use this equation, which is Pi is the internal pressure and Di is the internal diameter. S is the maximum allowable stress that you may refer to the reference table. And E is the welded joint efficiency. Also, you may refer to the welded efficiency joint table that I shown to you on the previous topic. So we have this minus 1.2 pi. Okay, for the spherical shell, to measure the thickness, you may use this equation. Okay, in designing the head enclosure, there are four types of head, which is the flat head, and also this is the dome head. Okay, the dome head we have the ellipsoidal head, hemispherical, and also torus spherical head. Okay, for the flat head, okay, usually it has a less pressure withstand capacity and used as cover for main waste and the channel cover for heat exchanger, and it forms flat end known as the flange only end. So you can see we have the radius, internal diameter, and also the straight face, and this is the height of the plate head. Okay, for the ellipsoidal head, it has a wider radius section, is available for pressure distribution, and it withstands with the maximum pressure as compared to other head because it has the uniform pressure distribution here. Okay, for the hemispherical head, okay, we have this design. So it has the strongest shape compared to other type of the head, and it resisting twice the pressure of a torus spherical head of the same thickness, but the cost is higher than a shallow torus spherical head. Okay, the hemispherical head are used for the high pressure, so we can apply this head for the high pressure. Okay, torus spherical head is the most commonly used enclosure. Okay, it can be operate up to pressure about 15 bar, usually above than 10 bar, and their cost should be compared with that of an equivalent ellipsoidal head. Okay, these are the equation to determine the thickness based on the type of the head. So if we have the flat end, you can use this. Okay, we have the effective or the nominal plate diameter. C is the design constant or dependent on the H constraint. PI is the pressure, internal pressure. S is the maximum allowable stress, and E is the joint efficiency. Okay, for the design of dome end, okay, these are the detailed equation. RC is the crown radius. Okay, this involve with the conical and enclosure. So we consider on the half or the cone aspect angle here. For the example, how can we apply the design on the pressure vessel which is subjected to the internal pressure, and also we apply the design on the head and closure. Okay, for this example, estimate the thickness required for the component parts of the vessel shown in the diagram. Okay, the diagram of the vessel are shown here. Okay, the vessel is to operate at a pressure of 15 bar and the temperature of 260 degrees Celsius. Okay, the material of construction will be plain carbon steel. Okay, so the material, the type of the material construction already provided. So basically, we can obtain the maximum allowable stress by referring to this material and also the temperature. Okay, what will be fully radiographed? So the value is 1, and a correction allowance for thickness, which is related to the additional thickness, is 2 mm should be used. Okay, so we start with the identify the design pressure. Okay, since it operates at higher pressure, so we may consider to have the design pressure which is above or 10% above the operating pressure gauge. So the given the given operating pressure here, so by considering the about 10%, so we can have this value of the design pressure. Okay, -1 because this is the we can consider the atmospheric pressure to determine the design pressure. Okay, design temperature at this given temperature. So using the carbon steel, so the maximum allowable stress by referring from the table 13.2, so the value is about 89 Newton per mm square. Okay, to determine the thickness for the cylindrical section, okay, this is the cylindrical design. So you using the equation shown to you previously, so including the corrosion allowance, so this is the thickness of the cylindrical section. Okay, how about to design the head in the on the pressure vessel here? So since we have a few type of head, so we may try to define all the thickness. Okay, we start with the dome head. Okay, try to apply the spherical here and also the ellipsoidal here. So basically it refer, how can we select this? You may also refer to the design a pressure. So for the spherical, use this equation and this is the thickness obtained. For the ellipsoidal head, okay, this is the thickness. Okay, so the detailed equation you may refer to this slide. So we have the spherical and also ellipsoidal head. So we can obtain the thickness. And then after that, how can select the best design is based on the thickness. So you can see here the ellipsoidal has the lowest thickness, which give us more economical aspect to be selected. Okay, how about we compare dome head to the flat head? So using flat head, okay, to determine the thickness, so we consider the box circle diameter, which is approximate 1.7, and full face gasket C, which is this value. And then after that, we can obtain the thickness around 111 mm, which is much higher than we use the dome head. So basically, for economical aspect evaluation, we may consider to use the lowest thickness to design this pressure vessel.